Next up, we'll try out a couple of application problems involving calculating the amount of work that gets done. So let's assume for a moment that we're in the 3D world and a force with a vector of 15, 12, negative 8 newtons moves a particle from position 10, 20, 10 to position 40, 30, 0. That'll be measured in meters, so that when we take the newtons times the meters, we'll have Newton meters or joules. So the question becomes, how much work is done? Now, we already have the force given to us in terms of a vector, so we're going to go ahead and leave it as is in terms of a vector. What we don't have is a displacement vector, but we do have an initial point and a terminal point. We can turn those points into a vector by taking terminal minus initial. So for the x position, that would be 40 minus 10. For the y position, that would be 30 minus 20. And for the z direction, that would be 0 minus 10, telling us that our displacement vector is going to be 30, 10, negative 10. Now, because I already have these in terms of their components, I'm going to do a traditional dot product to multiply these two things together. So work is equal to the dot product of the force and the distance. So we'll be taking our force of 15, 12, negative 8, and we'll be dotting that with 30, 10, negative 10. Multiply the corresponding components together and add the results. So 15 times 30 plus 12 times 10 plus negative 8 times negative 10. So we're seeing 450 plus 120 plus 80 for a total of 650. Now again, we should include units on this final answer. We multiplied newtons times meters. That would be either Newton meters, or if we want to go super classy, those would be joules. Now this one is still kind of theoretical because we don't typically think of a force in terms of a vector, and we don't typically think of a movement as, starting position and ending position. So let's consider this slightly more realistic version. Suppose that your car breaks down because it's Michigan, and that's what happens here, thanks potholes. So you call a tow truck to get your car towed. The cable creates a 20-degree angle with the horizontal, and coincidentally, the horizontal is the direction in which your car is going to be traveling, unless of course you believe in potholes, in which case it won't be traveling linearly, it'll be jumping up and down all over the place, and all in all it's just horrible. We'll assume that the tow truck is capable of exerting 2,000 pounds through that cable, and we're going to tow the car a half a mile. The question I'm going to pose is, how much work does the tow truck do to your car? Now in this case, you were given an angle, and you were given magnitudes of things. So what I'm going to use for this one, while it's true that it is the dot product of these two vectors, the alternative form says that we can do the magnitude of the force times the magnitude of the displacement times the cosine of the angle in between them. Now in this case, the magnitude of the force was given to us. That was 2,000 pounds. The displacement was half a mile. Now, if we want to go with the typical American units for this, we will need foot-pounds here. Good news is I know how many feet there are in a mile, and that is 5,280 feet. So what we're going to do is take our 1/2 and convert it into feet by multiplying by 5,280. That'll give us 2640 for our number of feet. We'll keep that there for a sec because we're going to need it. And then we'll multiply by the cosine of the angle in between them. That'll be 20 degrees. So this would be the exact form of your final answer. Given that it's a real-world problem, I would like to figure out real-world numbers for it. So we'll take that 2,000, multiply by 2640, and multiply by the cosine of 20 degrees. I'm going to verify that my calculator is in fact in degree mode before pressing enter, and getting that we did about 5 million foot-pounds worth of work. We'll call this 4.96 times 10 to the 6th foot-pounds. Now, you don't need to worry about significant figures or whatnot in here. When I give you problems for your tests and quizzes and whatnot, I will be sure to specify how I'd like you to round your final answer.